Yeah. Okay, so the topic today for this open exploration will be the history of the universe. So yeah, the history of the universe is a vast and complex subject, but it is also one of the most fascinating and important questions that we can ask ourselves. So where did it come from? How did the universe became the way it is today, and what is the future of? So I'll be going over all those topics. So first, we have the Big Bang. The prevalent theory for the origin and evolution of the universe is the Big Bang theory. According to the Big Bang theory, the universe began as an incredibly hot and dense point for 13.8 billion years ago. So in the early universe, the laws of physics were very different than they are now. They are today. So as the universe expanded and cooled, the laws of physics changed and new particles and forces emerged. So the Big Bang theory is the prevailing cosmological model for the observable universe from the earliest known period. So its subsequent large evolution, according to this model, the early universe was very hot and dense, as I said before, and it has been expanding and cooling ever since. Uh, the so the model accounts for the fact that the universe is expanding, the abundance of the light elements, the cosmic microwave background or CMB radiation, and large scale structure. Evidence for the Big Bang? There is a lot of evidence that supports the Big Bang theory. So that's including the cosmic microwave background, CMB, CMB radiation. This is a faint glow of light that is present throughout the universe. So that means it's like a very faint glow of light that is present throughout the universe. So you can see it somewhere. So it is thought to be leftover radiation from the Big Bang. That's why it's one of the evidence supports the Big Bang. So the expansion of the universe. So the galaxies are moving away from each other and at an accelerating rate. This is thought to be to the expansion of the universe. So the expansion of the universe is because of the Big Bang. So that's why. So the abundance of light everywhere. So the universe is made up mostly of hydrogen and helium. They're the lightest elements. So this is this is thought to be because the elements were created in the early universe when it was very hot and dense. So large scale structure. The universe is not smooth and uniform. Instead, it is clumpy with galaxies and clusters of galaxies. Meaning it is not very you know smooth or uniform. Instead, it is clumpy with galaxies and clusters of galaxies. So this is thought to be due to the way that matter was disturbed in the early universe. So now the Big Bang timeline. So the Big Bang is thought to have occurred about 13.8 billion years. So in the first few seconds after the Big Bang, the universe was extremely hot and dense. It was so hot that fundamental forces of nature were unified. As the universe expanded and cooled, these forces separated and the universe began to take on its current form. The universe was extremely hot and dense, as I said before, with temperatures over 100 trillion degrees. The four fundamental forces, which are of nature: gravity, electromagnetism, the strong force, and the weak force. So they were all unified into a single force. The universe was expanding rapidly at a rate that is difficult to comprehend. The first sub- subatomic particles such as quarks and electrons began to form. Wait one after about like 10 to like 35 seconds, the universe went through a period of very rapid expansion, inflation. Current inflation, universe expanded by a factor of at least 10 into the 78th power. I think this is actually like a very big number in less than a second. Okay, so after inflation, the universe continued to expand and about 1 to 6 powers. So the four fundamental forces of about 1 second, the first protons and neutrons. Over the next few seconds, the universe continued to expand and cool. But 10 to the 10 to the power. Okay. The first atoms of hydrogen and helium, the first galaxies formed about 400 million years after the Big Bang. So over the next few seconds, the universe continued to expand and cool. Then to the atoms, the first atoms of hydrogen. First stars and galaxies formed about 14 million years ago after the Big Bang. So what caused the Big Bang? There are actually no what caused the Big Bang because, however, there are actually a number of theories. I'll say that. One theory is that Big Bang was caused by a quantum fluctuation in the vacuum of space. Another theory is that the Big Bang was caused by the collision of two brains, which are higher dimensional objects. So basically, brains are like higher dimensional objects. So like the dimension we live in, so brains are actually like higher dimensional objects. That's one theory. Okay. So what was before the Big Bang? Okay, so we don't actually know what is before the Big Bang. Was although some physicists believe that the Big Bang was not the beginning of time, but rather transition from one state of the universe to another. So meaning some physicists think that the Big Bang was actually not the beginning of the universe, but it was just a transition from another basically another universe, you could say. The Big Bang theory is still under development and there is still much that we don't know about the early universe. So yeah, it's basically still in development and we still don't know that about the early universe. So like however it is the best theory that we have for explaining the origin and evolution of the universe. So the future of the universe. So the future of the universe, the future of the universe is still uncertain. So however, one possibility is that the universe will continue to expand forever. That meaning, so yeah, future would be that the universe never actually stops expanding and just keep going on for eternity. Another possibility is that the expansion of the universe will eventually slow, will stop, and then reverse it. So meaning it will then stop and then reverse itself, starting again. So causing the universe to collapse back. A third possibility is that the universe will eventually reach a steady state with the expansion rate and the rate of the star formation remaining constant. So our conclusion to the history of the universe is well. Oh yeah, Big Bang theory is the most widely accepted explanation for the origin and evolution of our universe. So it is supported by a wide range of evidence, including the cosmic microwave background radiation, expansion of the universe, abundance of light elements, and large-scale structure. The Big Bang theory has revolutionized our understanding of the universe, and it continues to be one of the most important and exciting areas of research in physics today. So now we talk about the cosmic dark. So from the Big Bang until about 40 million years later, the universe was in a state of darkness and fog. This was because the universe filled with hot, dense plasma, which is which is opaque to light. As the universe expanded and cooled, the plasma eventually cooled enough to form neutral atoms. This allowed light to travel freely through the universe, and the cosmic dark ages came to an end. So yeah, Q&A, question and answer. If you have any questions, you can ask them.
I have a
I'll
question.
stop.
I have a question.
Yeah, that's
So
what's your question?
okay. So my question is that, like, in the space,
Wait, wait, just say this. Can you mute in Teams?
what?
Can you mute in Teams? Because it's like echoing.
Oh, so okay.
Now ask your question.
Okay. So a question is that, like, in the space, do you know how much galaxies are there?
Well, how many galaxies are there in the entire universe? There are probably up to billions or trillions of galaxies, but I don't know the exact amount. But it's about like billions to trillions.
Okay. So I have one more question again. Like, do you know how the space are born? Like not the space, how the sun and how the solar system born? Do you know about it?
Well, how the sun and the solar system was born, I didn't actually research that one, but I'm not too sure about that actually. So yeah, I think I got like
Okay, I have one
what's
more
that?
question.
Okay, so like it was about like the solar system formed about 4.5 billion years. So it formed like many billion years after the Big Bang, so you could say.
Okay, thank you.
Yeah.
Then everyone is saying, not everyone. Like I see him in the shorts and YouTube, Instagram and all. Like after some years, the sun will be black. Is it true?
The sun will be what?
The sun will blast.
What do you mean?
Like I see, I see this message on YouTube shorts and a lot of Instagrams and social medias.
So are you saying the sun will become like a black hole?
No, I'm not saying like that. After some years, maybe it will be 100 or any years, the sun will be blast like. Did you got it?
I don't get what you're saying. Can you like
Uh, I will explain one more. Like, do you know about uh, uh, what you said? A black what?
black hole?
Yeah. That's the thing. I
So
forgot.
are you saying the sun would the sun become a black hole?
Yeah.
Actually, no. Like stars like the sun, like they're very like they're not actually big enough to become a black hole. So I mean, I think if the sun got like bigger and bigger throughout many years, like billions or millions of years, maybe it'll be big enough to become a black hole. But like as of now, it's not like it's too small to become a black.
Okay. So, what is the like main thing about black hole? What is
What
the
do you mean?
what is the interesting thing? Like
Well,
everyone.
basically
Yeah.
they are known as like the vacuum cleaners of space. So they just like so when you like when something gets close to it, the gravitational pull will pull it towards it and like suck it up basically. And basically you can't escape it unless you go faster than the speed of light, which right now is impossible. So you can't actually escape a black hole. So that's
Okay.
one thing.
Okay. What will we do if we enter on the black hole?
What will happen if you enter the black hole?
Yeah. What can
Well,
we do?
you like stretch apart, like very much until
Oh,
you're basically gonna get like stretched apart, basically, until you die, I
okay,
guess.
okay. That's it, my question.
Okay, Ghazal, you have a question? Please.
Yeah, I have a question. Yeah, so my question is, what are the current plans and ambitions for the future space exploration missions?
What What are the plans of what? Can you
What
repeat
are
it?
the current plans and ambitions of like the future space explorations?
I'm not actually sure about that. Sorry.
Okay.
Okay, Gazal, do you
Um,
have a question?
Yeah.
Okay, please ask it.
Oh, question. Okay. So like, what are some key missions and discoveries in the explorations of Mars?
some
Yeah, I can't hear you, Adit.
what?
Huh?
I don't know actually.
Okay.
Adit, you can be little more loud, okay? We cannot hear your sound.
Yeah, yeah. Basically, I said I'm not too sure about that. Um, Anyone else have a question?
Anyone else have any questions? Any doubts? Okay, if you have any doubts, we can wind up the session, right? Adit Aryan?
Yeah, I guess.
Okay. Okay, please come back to the class. All of you, please join back to the class. We can wind up the open exploration.